All right, we're going to take a look at derivatives of trig functions. So if we look at sine of theta and think of the slope, because we're talking about the derivative, we want to find the derivative of sine, we want to think about the slope. When theta equals negative pi, the slope appears to be about negative 1. At negative pi over 2, the slope is clearly 0. At 0, the slope is 1. At pi over 2, the slope is 0. And at pi, negative 1. And if we connect all these dots with a smooth curve, it appears to be the cosine curve. So the derivative of sine is cosine. Now if you look at cosine and make the same table, analyzing the slopes, you can see this looks like a sine curve, except it starts by going down rather than going up, and this is negative sine. So the derivative of cosine is negative sine. I don't know if you guys can hear Remy in the background here, but he's joined us for recording this lesson today. Say hi, Remy. So if we find the derivative of tangent using the quotient rule, derivative of tangent, well, tangent is sine over cosine, so that allows us to use the quotient rule. And low d high minus high d low divided by the square of what's below. Simplify that down. We know that sine squared plus cosine squared is 1. 1 over cosine is secant, so the derivative of tangent is secant squared. And if we use that same technique, we could find the rest of these. We're not going to derive them here. We'll just give them to you. You can make that a problem for yourself if you're curious to see how these come out. So now we have the derivatives of all 6 trig functions. And just go through here and look at some patterns. You'll see sine gives you cosine, cosine gives you negative sine. Every time you take the derivative of a function that starts with cosine, cotangent, cosecant, it always ends up being negative.